Guys, today we are going to solve this problem. It's problem B from division 1 and its ranking is 1800. So as always, we are going to introduce this problem by explaining the example here. So we are going to have two numbers in the input and it tells us the dimensions of the two-dimensional array. So for this one, we are going to have two rows and three columns. 1, 2, 3, right? And we are going to have a palm, and the palm's initial position is here, 1, 1, right? This is the location. And we are going to move this palm. So in this example, the second location of the palm is 1, 3, which is here. This is the second position, right? And we are going to move it further to 1, 2, which is here, the third position. And move it again to 2, 2, which is here, the fourth position. And 2, 3, the fifth position. And 2, 1, the sixth position. So we are going to move the palm in a way that travel each cell once, right? We need to travel all of those cells and only once. And additional condition is that we make some jumps between the move, right? For example, we jump from the first position to the second position, and the jump is 0, 2, right? We only move along the x-axis, right? So let's take a look at the jumps. So as we can see, the first jump is 0, 2, right? And the second jump is 0, minus 1, because we jump from this location to this location. So for the x-axis, we move to the -1, and for the y-axis, we didn't change anything, right? So we need to make sure that all of these jumps are unique, right? We can't jump the same jump twice, right? So that's the two conditions. One is that we need to travel each cells only once, and we need to travel all of those cells. And the second, we are going to use unique jumps. We can't use a jump twice. So how do we solve this problem? Before we get into this problem's solution, we want to solve a simpler problem first. Let's say if we have a one-dimensional array, right, like this, and we want to 1 second. Let's finish this one-dimensional array. Right. Let's say we have a one-dimensional array like this, and we are going to travel all of these cells so only once, and we are going to use unique jumps. How do we make sure of that? So we can use a simple strategy. We can start in from the original point and move to the last point. 1, 2, 3, 4, 5, right? This is index 5, so we are going to jump 0, 5, right? And then we move to the first empty cell, which is here, and then jump to the last empty cell, right? So the jumpings are decreasing, right? This one is 0, 5, and for this one is 0, 4, right? 1, 2, 3, 4, and for this one is 0, 3, 1, 2, 3, right? So it's constantly decreasing. So we can make sure that all of those jumps are unique. And we can make sure we can cover all of those cells and only cover them by once, right? So how do we make this solution um, how can we adopt this solution to the two-dimensional arrays? So we can adopt a similar strategy. That is, let's take a look at a two-dimensional array here. So it's a 5 multiplied by 8 two-dimensional array, right? So how do we make sure that we can cover all of those cells only once, and we can make sure that all of those jumps are unique. So same as in the one-dimensional array, we start from here, from the top left corner, and we are going to choose the farthest point as the second location, which is here. And then what we do, we're going to move like this. The third is here, the fourth is here, the fifth is here, right? You see the pattern. We are going to, like when we implement this movement, we are going to have a pointer here moving from this position down to this position, right? And another pointer here move from this position down to this position. And we are going to switch between the two pointers, right? We are going to have the first location here with the first pointer, and have the second position here with the second pointer, and then move the first pointer down, and we got the third location, and move the second pointer up, and got the fourth location. And eventually the first pointer will get to here, and the second pointer will get to here, right? And then we're going to move the first pointer to the right, right? And at the same time, we're going to move the second pointer to the left. So that is 5 here, 6 here, 7 here, 8 here, 9 here, 10 here, and 11 here, 12 here, 13 here, 14 here. Sorry, 14 here, and 15 here, 16 here, 17 here, 18 here. Sorry, 18 here, 19 here, 20 here, 21 here, 22 here. So we already covered the outermost part of this two-dimensional array, right? For the one-dimensional array, we also cover the outer part, which is this one and this one. Then get into the inner part, which is this one and this one. For the two-dimensional array, we are starting from the outmost circle and then move into the inner circles. So because we are going to end the outer circle here, so the next one we are going to choose is this one, the farthest one, right? So 23 is here. Then this is the first pointer now, right? And this is the second. And in the same way as before, we are going to move this guy up and left, and move this guy down and right, right? And eventually, when this circle is completed, the pointer will be stopped here, right? Because this is the first location in this inner circle, and uh, and then this should be the last, right? Um, and how do we choose the next starting point? Also, we are going to choose the farthest one in the inner circle, right? Now the farthest one is this one, right? And the second one is this one, right? Excuse me. So in this way, we can always use the farthest jump and cover all of those cells. So for the implementation, as you can see, I made a lot of submissions here. It's quite hard to debug because it has some tweaks. So you can take a look at my code. Essentially, I was going to read the dimension and then output double one if the dimension is just one cell. And then I'm going to use this guy to tell me that if I want to starting from this top left corner, or starting from bottom right corner for each circle, right? And if start is 0, then we are going to use P, right? P is the first pointer, right? PR is the row of the first pointer, and PC is the column of the first pointer, and QR is the row of the second pointer, right? And QC is the column of the second pointer. So if start equal to 0, I'm going to use start from the first pointer, and if start equals to 1, then I'm going to start from the second pointer, right? And these are some edge cases. So for this one is where we move the first pointer like really far from this place to this point, and if we want to go further, we should stop at that point, right? This is to bound it. And this guy is to make sure that if we have a circle like this, this guy, the first pointer will eventually arrive here, and this guy is already in the set, right? This guy is already visited, so we also need to stop here as well. And this part is where we make sure that the current cell is not traveled twice, right? And we output the location. And this guy is similar, right? We need to make sure that the second pointer is not going too far that exceeds the limit here, right? And this part is just a mirror. The only difference is that we output the second pointer first, then output the first pointer, right? That is the only difference. Let me see. For this part, this part is just to move the pointer further. So if the first pointer row is not arrived at the boundary yet, we can increase the row number, right? So essentially, it's like if we are at this position and move down, and this place is not the boundary, so we can move further down, and this place is not the boundary, and we can move further and further. So this place is the boundary, so we can increase the column number here, right? Which is essentially move to the right, right? I guess that's it. So the last call out is that I here is the index of the circles, right? So this is circle 0. This is circle 1. This is circle 2, right? So I guess that's it. Hopefully that's helpful, right? You guys have a great day, and thank you for watching.